Hi guys, it's your soon to be favorite math guy helping you out with sigma notation. So, first things first, what is sigma notation? You can think of sigma notation as shorthand or as a acronym for number patterns. So let's say we have this number pattern 2, 5, 7, right? And it goes on until infinity. This is our number pattern. But a sigma notation basically says, I want to sum this pattern. So we know from previous videos that to sum a pattern, we say Sn is equal to 2 plus 5 plus 7 plus whatever, right? Now, I want to sum this whole thing up until, say, I don't know, a term over here, right? I want to sum this thing up until, say, a term. What term do we know? We don't know it yet. So for interest's sake, we'll say this term is n is equal to maybe 101, right? So now, sigma notation, I already said it before, it is shorthand. So we can basically express Sn as a characteristic of its sigma notation. So now, as you can see here, we have a nice sigma sign, right? Now, this is a general formula that you can take down and you can note, right? So tk over there, then k is equal to a random value n, and then we have at the top m. So basically now, if we take note of it, what we are doing here is basically saying, I want to get the sum of this pattern. So this is our general form. I want to basically get the sum of this general form starting from the nth value, right, ending at the mth value. So to remember it, it's always bottom is the first, top is the last, and whatever is in front is what I'm dealing with. It's a mouthful. But anyway, like I said, bottom is the first, top is the last, whatever I'm dealing with is in the front. However you remember it. So now that we have that little gist, let's continue on with that specific pattern. Let's continue on with that specific pattern, right? So now, how would I write this pattern? How would I write this pattern to be specific in sigma notation? This pattern to be specific, how would I write it in sigma notation? So basically, there are three things we need to do before we can write it. First, we need to check the pattern. We need to check the pattern. What do I mean by check the pattern? What I mean is, what kind of pattern is this? Is this an arithmetic pattern? Is this a geometric pattern? Or is this a quadratic pattern? Then you get the general form. Get the general form. The moment you get the general form, you already have completed one of three aspects of this sigma notation. And then the last pattern is to get the last term, if it's there. 99% of the time, it is there. 99% of the time. So now that we have that, we are going to follow those steps. Check the pattern, get the general form, get the last term, right? So let me just We goodbye. We'll keep you there. We'll keep you there. So now, let's start with the first step. We are going to check this pattern. So we have 2 plus 5 plus 7. Usually, you always check if it's an arithmetic pattern first. And if it is an arithmetic pattern, then our life is a bit easier. So 2 goes to 5. 5 goes to 7. Hmm. Let's change that to a 3. So, yes, now 3 goes to 5 and 5 goes to 7. So, 5 minus 3 is 2. We're getting the difference here. Now, 7 minus 5 is 2. So that means now that we have the same first difference, it means that this pattern is arithmetic. Now that we know that this is an arithmetic pattern, we we have done the first step, check the pattern, get the general form. When you get the general form, you always get it in the form of Tn is equal to Bn plus C. Now, there are two ways to do it. You can do it with Tn is equal to A plus n minus 1 multiplied by D. Two ways to get it, but I prefer this way because it gets me straight to that form. So we know that B is equal to 2. It's the constant difference. We know that C is going to be equal to T1 minus B. T1 is 3. B is 2. Therefore therefore it's 1. Therefore we can say our pattern is Tn is equal to 2n plus 1. And it makes sense. Because if I was to say 2 times 1 plus 1, that's 3. 2 times 2 plus 1, 4 plus 1, that's 5. Yeah, and it makes sense. So put a box around it. Now, we move on. Let's now go, now that we have get the general form, get the last term. Now, for this pattern, we don't need to get the last term since we made a note over here saying that n is equal to 101. No, actually, we do need to get the last term since we're saying that n is equal to 101. No, actually, we don't need to get the last term. Yeah, but for my sanity's sake, I will write the last term just now. 203. So the last term of this pattern is 203. So let's say we did not have that n is equal to 101. So in order to do this, you would have just said 203. You're taking this is equal to 2n plus 1. Now you take away 1 from both sides. So now you'll have 202 is equal to 2n. Divide both sides by 2. Therefore, n is equal to 101. Right? Now that we know that n is equal to 101, we can now do the last step. Okay, let me move this. Let me move this to the side here. I think that's fine. That's fine. We now have the last term. So now, to write in sigma notation, you draw a big sigma sign. Right? You draw a big sigma sign. You open a bracket in the beginning. Then you will write the general term 2n plus 1. Right? You write the general term over there, 2n plus 1. This pattern starts when n is equal to 1, and it ends when n is equal to 101. This is the final sigma notation. Why? This is the last term. This is the first term. And this is the general term. Right? So that's how we do it. And I hope it helped you out.